All right, so here's part 2 of the Unit 2 lab, and I already put the baking soda down here while I was waiting for my other video to upload. And so now I'm adding the water. And again, I'm going to stir it. And why do I use a new stir stick every time? I use a new stir stick so that it's not contaminated. All right, so over in the corner you can see what happened. Go ahead and write down your observations for baking soda and water. And again, hit pause when you need to. I expect that that's what you're doing. And we'll go ahead and add the veggie oil. So for example, if I used this stir stick again, then I would get oil in all my other wells, and that could change my results. All right, so go ahead and write down your observations. Now let's do vinegar and baking soda. Ooh, you should know what this one's going to do, right? Baking soda and vinegar. Hopefully you've had a chance to do this if you've made a little volcano for a science project. If you haven't done this in real life, you need to. That's officially your extra credit assignment. Not extra credit, just extra assignment. So if you haven't done this in real life, you need to. Because what happens to baking soda and vinegar? It bubbles, right? It is supposed to bubble up. Baking soda and vinegar bubble. All right, so we are going to put that onto our observations. Now, hang on. Now, we can't just write that it bubbled because we know it's supposed to, but it didn't, okay? Because sometimes in labs, what we know should happen doesn't. And that can tell us things like, oh, maybe we mislabeled our bottle and this, in fact, wasn't vinegar. Maybe I accidentally put the water over there. Or, ooh, maybe that's not baking soda. Did we have that labeled incorrectly? So you can't just write what you think is going to happen in real lab. So we're going to put that at mix in lab, but in real life, we know it should bubble. Okay, that's what you do on the lab. It's okay to make little side notes of like, wait, this is what I know should happen, but wait, this is what really did happen. So that's important in science. Always write what actually happened, not what you think should happen, or not what, in this case, what you know should happen. All right, so let's go with the citric acid. And we'll put that in there. What do you think the citric acid is going to do? Give you a hint. Is vinegar an acid? It is. And look at that. I didn't even have a chance to stir it, and it started reacting right away. Yeah. So this is what we expected with the vinegar too. So that could tell me that maybe my vinegar is too weak. Maybe it's too dilute. Maybe there's too much water in my vinegar and that's why it didn't react. So again, it does tell me something. So this one though is what we expected from the baking soda and vinegar. This is what happens with citric acid. So for citric acid and baking soda, make sure you write down your results. And now we're going to do sodium hydroxide. Sodium hydroxide, anything that ends in OH or hydroxide is a base. Bases are opposites of acids. So do you think it's going to bubble? Oops, no. And there you go. That's our observations. So baking soda is a base. We put two bases together. This is what happens. We put a base and an acid together, and this is what should happen. All right, so make sure you got all your notes written down. All right, now we're going to go through and test the sugar. And so again, we're using the scoopula, and we're putting 1 scoop into each of the wells. Again, I'm only using the outside wells because in this program, they're the only ones we can see for a side view. And you are going to be doing this in the future lab. And so that will be an important tip to keep in the back of your mind. And let's go ahead and add some water. So you've probably done this in real life. For example, if you've ever made Kool-Aid or lemonade. So you should have a good hypothesis for what's going to happen with this one. And here we go. And again, we don't have enough water to dissolve all the sugar. So it's kind of like if you make extra sweet Kool-Aid and you got this Kool-Aid powder and the sugar that settles to the bottom. That's the case of this. It's called saturated. It's when there's not enough liquid to dissolve all the solid. So, all right, make sure you wrote down your observations. And we'll go ahead and do the vegetable oil. And the reason they use vegetable oil is because oil has very different properties than the water. Remember from our chromatography lab how different it reacted on the paper as far as it being a mobile solvent and that it didn't spread the ink out very much. So oil and water have very different properties, which again, I'm sure you knew from real life. And in chemistry, we take advantage of that to get different reactions. All right, so here we have vinegar and sugar. All right, write down your observations. And oops, I will go ahead and do citric acid and sugar. And go ahead and write down your observations for citric acid and sugar. And then last, we have sodium hydroxide. So hopefully you've heard me say sodium hydroxide enough that you'll remember NaOH is sodium hydroxide. Na is sodium, OH together is called hydroxide. And that's something we'll be talking about in the unit with bases and acids, as well as when we make chemical equations. All right, so go ahead and write down your observations for that one as well. All right, and last, I went ahead and I put vinegar into all of the wells along the bottom. And now we're going to add water to this. Oh, maybe. There we go. It wasn't letting me for a second. And you might already know what's going to happen based on what I was talking about earlier, in that vinegar can actually be diluted with water. And so for this one, we would just have to say no visible changes. So no visible changes because that's what we have. Something might have happened, but nothing that we could see. So no visible changes. All right, and we will go ahead and add the oil now. And what are you expecting to happen with the oil and vinegar? All right, and so they went together and give me a chance to mix it up here. But maybe there'd be something right away, so I figured it was worth checking. And, well, since I just stirred it, it's pretty well stirred. Although normally you might expect some separation, but you gotta write down what we saw. So we would just have to put looks mixed together. All right, so go ahead and looks all mixed. And vinegar, we're just adding more of the same. So I'm gonna skip that one. We'll just write Na or skipped on the vinegar and vinegar because you're adding more of the same thing, so we're not gonna notice anything. All right, so let's go ahead and add some more acid to our vinegar. What are you expecting to happen there? So we added two acids together, and yeah, I'm gonna have to go with no visible changes on that one. And then last, we're adding NaOH. What does Na stand for? Sodium. What does OH stand for? Hydroxide. So we call that sodium hydroxide. And that's a base, so I'm thinking we, oops, it would help if I clicked on the right well, huh, and stirred it. Let's try again. There we go. And I'm thinking we might see some kind of reaction, but it looks like it just all mixed. All right, now I kind of want to try something else because remember how our vinegar didn't react with our baking soda, right? It didn't react very well. So I'm wondering if it's just not a strong enough acid to react. So I want to try citric acid and sodium hydroxide and see if that does anything. And the fun part about virtual labs is you can try anything and you don't have to worry about the safety. Whereas in real life, you'd actually have to get permission to try something because if not, you can fail the entire class. Seriously. You can fail an entire class for doing an unauthorized experiment in real life. And, I would have thought that one would have bubbled. All right, you don't have to write anything down for this on the paper. I just wanted to try it out. So now what I'm going to do is I am going to hit Save Lab. So right down here it says Save Lab. Wow, it has been set. Okay, so if I quit and restart the lab, you'll automatically resume from this point. So time will continue to pass normally. So when you return, chemical reactions will progress. You may delete the save point by clicking the delete save point link below. So I am going to wait and come back literally a day or two later and check and see what's happened as far as evaporation. I do want to note something though. Look at the oils. Look at all our oil here. Okay. And now look over here. What do we notice here? You know, I think we're going to have to write down some different observation here for this one because it's definitely a lighter tan than the rest. Now, it could just be because it's diluted, and that's okay. But we still need to write down the fact that it is lighter than the rest. So let's go back to where our data table is. There we go. And looks all mixed. It is lighter than all the other wells with oil. So let's do that. All right, so now we're going to wait a few days, like I said, and I will start with the part 3 recording at that point, and we'll go ahead and see what everything looks like after it had a chance for evaporation to occur.